Hello everyone and welcome to class of 5G deployment cases. Today in this class we are going to discuss about various cases of 5G deployment. So mostly we can have three cases of 5G deployment. Case 1 is non-standalone 5G with 4G and 5G in a similar mid-low bands. Both 4G and 5G NSA 5G radios are deployed in a similar mid-low band frequencies, which means that they will have similar coverage areas. The greater capacity and high speeds enabled 5G new radio spectrum means that operators are likely to deploy it in high traffic areas like in cities and urban areas. If operators need to deploy 5G in a new unique frequency band, then this NSA deployment scenarios require additional radios to handle the separate frequency. Mostly other equipment remains the same. In this case, 4G and NSA 5G radios are deployed in similar band frequencies. We can co-locate all radios and connect to the existing core network. Here, deployment of 5G in a way that has already an EPC network which supports 4G. If the 5G radio access network carries more traffic, operators need to add additional baseband capacity so that it can provide additional processing power. We can have embedded RAN functionality. There we can reuse the core network. We can reuse the 4G baseband with 5G, S1 over microwave fiber or copper, or eCPRI over fiber. And with network function virtualization infrastructure available, there is a reuse of data center and cloud infrastructure, F1 and S1 over microwave fiber or copper, and eCPRI totally over fiber. Coming to the next case, which is case number 2, here we can have NSA 5G with 4G in low and mid bands and 5G in high bands. Here in this case, 4G is deployed in low frequencies while NSA 5G is deployed in high frequency. 5G cell coverage will be smaller than 4G, especially for uplink. It may be possible to co-locate 4G and 5G radios. Some new sites will be needed outside the existing site grid so that we can achieve the continuous coverage. Some operators will want to deploy 5G in this way to gain new capacity and extremely high throughput that the wider spectrum mostly offer. 5G radios are still anchored in 4G and existing core and transport networks are reused. It includes enhanced mobile broadband, FWA in selected areas. Case 3 is that we can use standalone 5G in low, mid and high bands. In this case, 5G is deployed in combination of all the low, mid and high bands. 5G radios will be deployed as a standalone units with dedicated connectivity to the core network, fulfilling the new 5G specifications, which means that this solution will be available later than NSA. In a longer term, it is likely that all deployments of 5G will support standalone as well as non-standalone with interworking options between the low, mid and high bands. This is an important for 5G deployment. So standalone 5G deployment are likely to be used in private and enterprise networks like in industrial IoT, in self-contained factory or campuses environment. These are the deployment cases. Thank you so much.